Thank you. Okay, such a pleasure to be here, first of all. And I'm a bit excited because this is my first time talking at GOTO, and it's lovely seeing that there's people interested about Gleam. So, as you've heard, my name is Giacomo. I'm a bit of a functional programming nerd. Maybe you've guessed it if you've talked to me in the halls. The thing I'm most proud about, though, is I'm part of Gleam's core team. So I'm helping with the language, with the tooling, compiler, and of course, bug fixing. So today I will be your guide through the Gleam language. We're going to be learning what Gleam is, of course, why it's interesting, what it's bringing to the table of programming languages, and why you should start learning it today. Also, by the end of the talk, hopefully, you'll have all the resources you need to keep your Gleam journey going, hoping that it doesn't stop today after my 40 minutes of rambling. So what is Gleam? Well, if you've never heard of it before, Gleam is a friendly language for building type-safe systems that scale. There's quite a bit to unpack in just a single sentence, though. What does it even mean for a language to be friendly? Also, type-safe systems, so we're talking about static typing. And those systems also scale. That's quite an interesting word, quite alluring. So what's Gleam's superpower that allows us to build systems that are reliable, that can scale as we need them to? Our journey today will be guided by these three principles: friendliness, type safety, and scalability. And of course, being a code-centric journey, we'll have a look at many code snippets. Don't worry, I know it's the last day, so they're not going to be extremely hard to follow. And I hope you'll appreciate how Gleam's syntax is familiar, one could say, reminiscent of many mainstream programming languages. So one could even say friendly. It's just one of the many puzzle pieces that is working towards making Gleam a language that is easy to pick up. That's by design. We want Gleam to be simple, and anyone could really learn all there is to know to the language in just a couple of afternoons. And that is intentional. If you're learning Gleam and functional programming, well, that might be new concepts for you, and that's the fun part, you get to learn something new. But if at the same time you're learning these new cool things, you also have to fight with the language. You have to juggle different things in your head. How do I write this? How do I do this? Well, it's going to be twice as hard. And so the syntax, being reminiscent of, one could say, JavaScript, Rust maybe, is actually a really empowering thing, because now the language won't get in the way of you learning. So if you've had any exposure to a mainstream programming language like JavaScript, and who hasn't by 2024, you should have maybe a rough idea of what is going on here, even if you've never wrote a single line of Gleam before. So we are defining two functions: the entry point of the program and a greet function. Here we don't write function, we just write fn, but it's the same thing. And the greet function is taking a name as input, and then it's printing something to standard output by joining those strings together. It does that with that diamond operator. It's just the less sign and greater sign. And when you see that io.println, it means we are calling the println function coming from the io module. You can also do that in JavaScript with imports. A module is basically a way to organize Gleam's code. And standards library is already having many useful things like modules to work with I/O, with lists, results, whatever that might be. And then in the main, we're doing something that is just a step above the simplest hello world I could come up with. That is, we are using that function we've defined to print many greetings. So we are saying hello Lucy and hello Copenhagen. And Gleam also has some nice pieces of syntactic sugar I'm going to be using in the slides that I'd like to show you, and one of those is the pipe operator. Basically, what that is doing is it takes what comes before it, and then it passes it as the first argument of the function. So this is virtually the same as writing this, where the function is the list is the argument to the function, but now it's a bit nicer to read. And if you squint hard enough and maybe cover one eye, you'll see that that is basically like calling the forEach method on an array, on a JavaScript array. Don't get me wrong, Gleam is not object-oriented. It doesn't have methods, it doesn't have classes, interfaces, whatever thing object-oriented has. The only thing it has is data and functions, and some nice syntactic sugar to make things easier to read. And when I say data and functions, I'm not really kidding. One thing you'll usually hear from people in the Gleam community is, all you need is data and functions. There's really not much more to it. And so it's quite simple. It feels a bit exhilarating at first, getting to something that is so, like, minimal. Okay, now that we've got the basic hello world example out of the way, so far so good, right? Okay, let's get to the first point. Gleam is type safe. So Gleam has a strong static type system. Basically, everything in your code has a type. A number is an integer. You have strings, you have lists, dictionaries, whatever that might be. Siri going off. So the compiler can tell what's the type of the different things in your program and make sure that you don't mess things up. The way I like to think about it is like having a pair programmer who's always by our side and is constantly reading through our code and knows a lot about our code base and makes sure that we don't make any mistake that would result in our code behaving strangely at runtime or crashing. And this pair programmer has a really nice property. He's never tired. He's tireless. And I think that's quite valuable because we programmers, humans, do get tired after writing code for a long time. So having someone, or something in this case, who's by our side and is telling us, wait, maybe here you made a mistake, this thing wouldn't work at runtime, it would explode, it would make your system fall down and crash. And so this is, I think, really valuable. Let's get to our first example. We have the greet function, and here we say it's taking a string as input. So as long as we say greet Lucy, we will see hello Lucy instead of output. What if we make a mistake? So what if instead of passing something that is a string, maybe after a refactoring, whatever that might be, an integer ends up there? Now here I'm using just the literal number 11, but imagine you have some variable, some thing that is returned by another function and you pass it around and then it ends up there. Well, as I've told you, this pair programmer who's always by our side is going to tell us, well, that is wrong. And I was expecting this to be a string, but it actually is an integer. This doesn't work. So this is most likely something you don't want to be happening. And this is the first error message I'll be showing you today, and hopefully you'll enjoy how, like, straight to the point, but also clear and explicative Gleam's error messages are. That's how the compiler can feel someone who's friendly and not someone who's there to like, scold us for making mistakes. And the nice thing is also, it's not only telling us that something is wrong, it's also telling us, well, I was expecting something else, and it's going to tell us. So it's not enough nowadays for a language to be like, well, there's a problem in your code, go figure it out, don't write bugs. The language has to be much more informative. Go the extra mile and help the programmer try to figure out what is wrong with their code. I think languages like Rust and Elm really has shown us what good error messages should look like. And most notably, in many languages, you would be able to do something like this, to pass an integer, and that gets magically mushed into a string or something that can then be printed automatically. And here we get to one of the many the core philosophies of Gleam. That is, Gleam is an explicit language. There's always this tension when you're designing a language. You want maybe a language that's super powerful, that allows you to squash as many things into a single line and be extremely clever and do as many things as possible with as little code as possible. And while the code writing is undeniably a lot of fun doing that, well, the code reading starts getting harder and harder. Because now the code relies on some hidden knowledge that is shared between you, the developer, and the compiler, and no one else. So for someone to come in and read through your code and understand what is going on, they need that knowledge that is not explicit in the code you're writing. And so Gleam decides to favor being explicit. You'll have to type a bit more. That's undeniable. But now you get code that is much more explicit about what it wants to do. It doesn't rely on some hidden knowledge that it's not accessible, that is only accessible if you know a slew of unknown rules or magic compiler stuff. So here, for example, I wasn't lying when I said all you need is data and functions. You just add another function call, and you're turning that integer explicitly into a string. So now if you're reading it, you know that that is being turned into a string. Keeping on with this being explicit idea, well, Gleam also has no nulls and no exceptions. And I think that's like one of the best things one could ask from a language. I think we can all relate with the pain of seeing a null pointer exception or undefined whatever pop up in the console, and it's just painful. So let's make an example that is a bit more involved. Don't worry, this is going to be probably the hardest bit. It's all going to be downhill from here. We are making an HTTP request. And you can see how the pipe operator is really nice here. It's describing this pipeline of transformations. So we are building a basic HTTP request. We are setting the host, the path, and then we are sending it using an HTTP client in this case. We get a response back, and then we want to print the response body in this case, or do whatever might make sense here. In this case, it's just going to be some JSON blob with the info about this Pokemon I'm asking to the Poke API. But if you think about it, an HTTP request is something that could fail in myriads of ways. We could get a timeout, we could lose the internet connection, the server might not ever answer, and so the body might not be there. So how can this work? Well, if Gleam doesn't have exceptions and doesn't have null pointers, well, this cannot possibly work, because there's not going to be anything in the body. And you're right, it doesn't work, and the compiler, this pair programmer, knows it. And he's going to tell us, hey buddy, the body is not actually there because you're not just working with a response. You're working with something that is a bit more complex, with a result. So it's all about being honest, being explicit. A function cannot lie about the fact that it can fail. So making an HTTP request won't always return a response, but it can sometimes return something else, a failure. And so this has to be explicit, and the function is returning a result in this case. And that doesn't have a body. A result might be wrapping a response with a body, but we need a way to access it. So how does this work? Well, a result is just some other piece of data, like everything else in Gleam, just data. But it's quite peculiar because it can wrap other things inside it. The way you build a result is using two different constructors. If you're used to object-oriented programming, you might have an interface result and then two classes, OK and error. So these two constructors represent both success and failure in this case. And in both cases, you can add additional data. So not only you have a success case where you have your response or whatever that might be you were looking for, a user, a Pokemon, whatever, but you can also have the error case where you have maybe some information about why the thing you wanted to do failed. Well, I couldn't make an HTTP request because I had no internet connection, because the server didn't reply in time, and whatever the reason might be. And the thing is, both OK and error are just results. So in this case, we have a result that is wrapping an integer if everything works out fine, that is that 11, or a string if something goes wrong, and that string might be an explanation in human language of what has gone wrong. So when we have to deal with a result, we have to deal with the possibility that that might be OK, but it could also be an error. And to do that in Gleam, we have pattern matching. That is a really powerful feature. You can think of it as some sort of switch, if you're used to Java, C languages, but way more powerful. We're not going to go in depth into that, but basically what it allows you to do is to act based on the shape of some data that could be many different things. So here, for example, the result might be OK, and then wrap finally a response we can use, and then we can access that body that we know for sure is going to be there because it's explicit and it says, OK, everything worked out fine, it's OK, so you can do this. But if something goes wrong, well, then now we have to deal with the error. You might want to return an error yourself and pop that up the call stack. But you have to be explicit about it. Or you might deal with it. Maybe put in place some retry logic, or whatever that might look like for your use case. Here I'm just printing a string because it wouldn't fit in the slide otherwise. And the nice thing is if we are pattern matching on something, on a result, on whatever that might be, the pair programmer once again looks at our code and is going to make sure that we deal with everything, with all possible values. So if we forget something, if, for example, we forget to deal with the error case, and it's already hard because you write the OK, so you know that an error should be there, but let's say you forget about it. Well, it's impossible to do that, because once again, the compiler rises up and will tell you, wait, this expression doesn't handle all the possible cases, and it's going to explain you all the cases you're missing. So now you are forced to deal with the possibility of failure. And that's really empowering, because as developers, we're really good at ignoring and forgetting about the myriads of ways our code could fail. And having someone who's going to tell us, well, actually, your code could fail here, remember to handle this, is really powerful. At the end of the day, though, we might talk about types, and I think it's really fun, I would never stop about it, but the reason we do that is to have that red squiggly line in our code editor and a super fast feedback loop. Because now the errors can be moved from runtime to compile time. We can know that if that red squiggly line goes away, well, then our code compiles, and there's no possible way for our code to explode in unexpected ways. And again, that's really powerful, because an error that you're missing maybe could slip through your tests and end up in production code. And then the way you have to discover it is for someone to use your product, the product explodes, and then they report an error. And now, a week, a month, a year after introducing that bug, you have to go back to the code, see what was wrong, and you're lucky if all the reports, logging, whatever, help you there. And now you can try and figure it out, but it's going to be harder. And especially the longer the bug stays there, it's going to be harder and harder to fix it. So if we can move and make sure that many errors are taken care of as we are writing the code, well, that's going to save us a lot of testing first and a lot of time. I was reading just yesterday, so one last minute change to the slides, this lovely blog post from a member of Gleam's community, Aileen, and she was saying that looking at her Gleam code makes her feel calm. Because she knew, also, she's putting Gleam in production. This is production code. So someone is doing that. And she says that looking at Gleam code makes her feel calm, because she knows she can rest assured and have the ease of mind that that code she wrote is not going to blow up in unexpected ways. Because again, the compiler, this friendly pair programmer who's by her side, is helping her figure that out. Second point, Gleam can scale. How does it do it? Well, for languages, nowadays it's important to take into account many needs we might have. To work in distributed concurrent systems, for example, to help us build systems that are fault tolerant. The way Gleam does that is by leveraging an amazing runtime, that is the Beam virtual machine. To do that, Gleam compiles down to Erlang code, and that in turn is run by the Beam. And Erlang and the Beam were born in the 80s from some really specific needs of industry. So imagine you're at Ericsson and you have to write software for phone switches, that is a thing, and those have to be extremely reliable. They have to be fault tolerant. You don't want an error to bring down your whole phone network. You might have heard of the 9.9 of uptime of those systems that was achieved with Erlang. And also, those systems also had to work in highly concurrent, distributed systems. If a phone switch could only handle a single phone call at a time, well, that wouldn't be quite useful. And so that's how Erlang and the Beam were born. No other language was up to the task, could fulfill all those needs. And so, these ideas of fault tolerance, concurrency, distribution were baked into the runtime. You might have done some concurrent programming. I have done my fair share at university, for example, using OS threads, locks, mutexes, whatever, semaphores. And you might remember that's quite painful to get right. The Erlang and the Beam virtual machine decided to go another way and to rely on something different. The basic unit of concurrency is the process, but you don't have to think of a process as an OS process that is heavyweight and you can't have many of those and you have to share memory and use locks, mutexes. A process looks basically like a sequential task and then can communicate with others by exchanging messages. So you don't have to share memory and you don't have to use mutexes, locks, whatever that might result in code that's really hard to write and reason about. Also, those processes are super lightweight. It's simple to spin up many of those because they have a small memory footprint. You can spin one up in no time. If I recall correctly, it's just a couple hundred words of memory per process, so they're super lightweight. They can be terminated quickly, and they can be scheduled automatically by the Beam to take into advantage all the cores of the physical machine beneath it. And so you get all those amazing processes, and you can span hundreds of thousands of those, and the Beam would deal with those without batting an eye. So Gleam really shines as part of a wider, richer ecosystem, the ecosystem of the Beam languages, Erlang and Elixir, just to name a few. And we wanted for Gleam to have a great FFI story, so you want to be able to access this ecosystem, these really amazing and powerful libraries that have been developed and battle-tested through many years, since the 80s basically. So Gleam's FFI is pretty straightforward. Basically, you define a function and you say to the compiler, well, this is external, this is going to be implemented in Erlang, don't worry about it, or in Elixir. And then it's going to work out just fine, because the compiler will then call that function at runtime. And the nice thing, it has also zero overhead, because by the end of the day, when you compile your Gleam code, it's just going to be turned into Erlang. And so this is just another Erlang function call. So now we get access to loads of amazing libraries. For example, Elixir has some great libraries to do tensor math. And using those, it's as simple as saying, well, I have my Elixir dependency, and I can use it by saying it's an external function. It's coming from some Elixir written code, and now I can just do tensor math in Gleam without having to go through the undertaking of having to write and implement a super fast, optimized, and amazing tensor math library. That would be a huge undertaking. And so Gleam can take advantage of those amazing libraries. But it also goes the other way around. I don't know why Siri keeps popping up. Okay. Gleam also goes the other way around. So Gleam code can be used by other Beam languages. By virtue of compiling to Erlang, well then any Erlang process can just use Gleam code once it gets compiled. And so if you start writing something in Gleam, you might want to start maybe adopting Gleam in your project incrementally. You might have a big Erlang codebase, and maybe there's some places where that type safety would really be nice, would make sure that you have to write less tests and maybe your code is a bit more reliable there. And so you can just write that in Gleam, compile it to Erlang and start using it, just like that. And Gleam also has some other really nice things up its sleeves. So for example, also, and here's an example of how you use it from Erlang. If there's anyone who's doing Erlang or Elixir in their code base, it's just another function call. And we want that generated code to be human readable and nice to use. It's not just some super optimized format that's impossible to use from other projects. You can get that Erlang code, and most of the time it's better than what I would have written by hand, and just use it. And another really nice thing Gleam has going on is that Gleam can compile to JavaScript as well. So you have two different compilation targets here. And that makes for a really nice full-stack development story. Because on the backend, you can use the Beam. You can use this amazing battle-tested runtime that has proven great for many, many workloads. For example, to make web servers. that are long-lived, that need to be fault-tolerant, that need to use resources in a smart way and also handle with many concurrent requests. And on the front end, you can leverage the type safety of Gleam. So you can stop writing code in JavaScript or whatever the language you might be using and enjoy the absence of errors in the browser console. And I think that is quite nice, because now you have a project that is using the same language on the front end and the back end, and now you can share code between the two. You can share type definitions. You can share encoders and decoders for all the data that has to cross that network boundary. And you don't have to write it twice in two different languages, because it's just a single language, and now you are doing full-stack web development in Gleam. And Gleam has some amazing libraries to do that. For example, there's Wisp to develop backends and web servers, and Luster, that is a Gleam take on the Elm architecture to do front-end. And so now you get some really nice frameworks that really feel very mature, despite Gleam being a young language, that you can use and start adopting in your code base in an incremental way. You can compile your Gleam code to JavaScript and start using it from other JavaScript code, like if it were some handwritten JavaScript. And hopefully, by looking at all the error messages and the code, now you might start getting an idea of why Gleam is friendly. The compiler really tries to go the extra mile here, to make the errors as clear, as explicit and precise as possible. So let's say you make a typo. Now the compiler can pinpoint to the problem and tell you, well, you're trying to access a user, it has a name field, but you wrote NAM, did you mean name? And now you can go and fix your code. Again, you have a super fast feedback loop. You don't have to run your tests. You don't have to run your code and feed it to some user or in production, whatever that might be, to find out you made a typo and now things are exploding. Because it's the compiler that's telling you as you write. It's that pair programmer who's helping you as you are typing. But that's not enough. A language might have an amazing runtime. It might be compiling to Erlang, to JavaScript, allowing you to do full-stack web development. It might have great error messages, and still that's not enough. Nowadays, you can't just give people a compiler and tell them, go do your thing. It's not what happens. There's loads of toolings and things we give for granted that actually make or break a language, that make a language pleasant to use, friendly, that make a language something that you can recommend people and not just say, well, it's fun, but I wouldn't really use it in production because it's a bit of a pain to use. For example, you need a build tool to build your project, to build a thing that you can run, to package your thing and publish it online on some package repository. So now you also need something to manage your dependencies, a package manager. You need a formatter to make your code look nice. You don't want to go through hours of exhausting bike shedding about what code looks best and where the comma should be, because now two coworkers cannot come to an agreement on what looks best. You also need editor integration, and I think that's the main thing you really want. You want syntax highlighting. No one wants to be typing on some white text on black background. So you want syntax highlighting. You want a language server that's helping you write your code. And we kind of give those tools for granted when we're using any mainstream language, because it's just there until it starts getting painful, until you have to go through tooling hell to find the best combination of different tools you can then compose together and get something that is usable and nice to use. And every project will have their favorite tool, their favorite standard or configuration file to use, and now you have to learn something new every time you move to a different project. So Gleam, putting developer experience as its utmost priority, has all of those things built in. So when you're installing Gleam, you get a compiler, you get a build tool, you get a package manager, a formatter, you get code editor integration, and a language server, all in one neat little package. And you don't have to worry about all the tooling mess that might be out there, because you get that out of the box. So I think it's time for something a bit scary that is showing you what it actually looks like to get started with a Gleam project and how nice it can actually be. So here we are creating a new project. And to do that, again, as simple as Gleam new, now it's going to scaffold everything for you. And as you can see, it's Git project by default, so it's taking care of that for you. I think it's quite nice because I can never be bothered to do that by myself. And you have a basic project with some tests that you can look at. They're just an example of what a unit test looks like in Gleam. So you know how to move forward, what to do next. Now let's go here, and let's try implementing that HTTP request thing we were doing earlier. So we need some dependencies. We need an HTTP client. Again, Gleam comes with a package manager built-in. So adding a new dependency, again, it's as simple as Gleam add and then the dependency you need. It's going to take care of version resolution and everything for you automatically. You don't have to muck with configuration files and whatever that might be. Now that we're done with that, we can start coding, and as you can see, we have editor integration. Here I'm using Z because it's quite nice. We have a person in this Z contributors who is really into Gleam, so they've been super nice with us. But it works with all the editors you might want, so Visual Studio Code, Z, terminal-based editors I don't know the name of, whatever. So here we can create a new request, and as you can see, the language server is going to show us what we can use. It's going to take care of auto imports. Documentation discovery, you can hover over things and see whatever is going on. So for example, we can set the host to PokeAPI. We can set the path, and again, the language server can help us unless I make horrible mistakes here. So we can say Pokemon and then a star-shaped Pokemon just to stay relevant to the theme. And now we can send the request. So HTTPC, which is Gleam's client.send HTTPC. And then we're good to go. We can bind these to a variable. So this is the result we get back. And as I've told you, in Gleam, everything has a type. And just by hovering over things, you're going to see those types. So you can just ask the language server, the compiler, to tell you what's the type of things. And now you see that is a result and that is unused. So what do we do with results? Well, we pattern match on those. So we can do some pattern matching. Case result. And keep going. Again, you see the red squiggle as you're typing. And it's telling you, well, these patterns are not all the things that could happen. You're forgetting about the error case and the OK case. You're not handling those. And since the compiler and the language server know so much about your code, they can help you, for example, by adding all those missing patterns for you. So you don't have to type those by hand, which is extra nice. Here we're just print lining something. And here we can do something with the response. So now that we do have that, we got our hands on that response because we know that things worked out fine, we can, for example, print line the response body, which is just going to be a JSON blob or whatever that might be. Response and response. And things just work. We can run this. And probably you're going to be seeing some JSON that is all the data about the Pokemon. Maybe this is not super nice to look at, so we can try doing something different. That is printing the status code. So what we can do is, if we write a pipeline, for example, response dot, and you can also see all the fields you can get a hold of. So here we also have a status. But now we get an error. Again, the compiler knows that we can't do that. There's no magic implicit conversion that is going to turn that integer into a string for us. We have to be explicit about it. Because the argument is an integer, but the function was expecting a string. So we have to add a new step to this pipeline of transformations. And so here, it's just going to become a int to string, and we can import the module automatically. Now we're good to go. We can run it again, and again, running the code as simple as Gleam run. You don't have to go through hoops to run your code. It's just that simple. Gleam run, and you're good to go. If you want to run your test, well, that's Gleam test. Here we have just an example test that is not going to fail. And okay, now that is out of the way. I'm quite happy that it didn't explode. And I think it's time to wrap things up. So Gleam is a friendly language. that puts developer experience as its utmost priority. It wants to make the experience of using it as smooth and as simple as possible by giving you loads of tooling out of the box, and it just works. You don't have to go through the hell of having to decide which combination of tool, which configuration is better for your team. Gleam is also type-safe. So you always have this extremely valuable pair programmer who's really smart and thinks really hard about your code and is going to tell you what might go wrong. And again, it's scalable. It can compile down to Erlang using an amazing runtime to get features like concurrency, fault tolerance, dealing with highly distributed systems. So what now? Let's say now you're interested about Gleam. You would like this journey to keep going. Well, there's many great resources as well. So first of all, I think the best place to get started is Gleam's language tool. It's an online interactive tool. Since Gleam compiles to JavaScript, it runs in your browser because it compiles your code down to JavaScript and then just runs it. And it's great. It will get you through all the features of the language. And there's really few of those. Gleam is a simple language, once again. And so you will probably be able to go through the entire thing in a couple evenings. If you're more like the code kata person, you would for sure enjoy the Gleam's exercism track. So what you can do there is solve exercises, be introduced to functional programming concepts, and also ask for feedback from other people from the community, and they will try and help you with your problem if you're struggling to do something. But I think the best place to be is Gleam's Discord. Gleam has really an amazing community. What I love to say is you get in for the language, but you really stay for the community. It's full of lovely, caring people. They're always happy to help someone who's just getting started with Gleam. So if you have any questions, any feedback, if you're stuck and you don't know how to do something in Gleam, please do reach out. Also, you can also reach out to me. So if you want to ping me, I never shut up about Gleam, so come talk to me. I might look shy, but I will talk to you, and you will want to kill me after that. So my email, I'm on Twitter, GitHub, Open Issues, whatever you want to do to reach me, please do. And that's it. That was my talk. So thank you so much for listening, and please remember to rate it on the GOTO app.